Example 1, find the x-intercepts of the polynomial functions. For example A, we have something that is already in factored form. So to find the intercepts, to find the x-intercepts, we can just let this whole thing equal 0. So I'll set this equal to 0 like this. When we split this up into all the different components that can equal 0, the very first component we have is a 2, and that can't equal 0, so we can just kind of ignore that. So we get that either x minus 4 is equal to 0, or x plus 1, or x minus 6. So we're getting x is 4, x is negative 1, and x is 6. So for our x-intercepts, we have 4, 0, negative 1, 0, and 6, 0. For our y-intercept, we're going to plug 0 in for x, so we're going to find f of 0, which would be 2, and then we'll have 0 minus 4, 0 plus 1, and 0 minus 6. So 2 times negative 4 times 1 times negative 6. Let's see, that's going to be 24 times 2. That looks like that's 48. So our y-intercept is 0 for x and 48 for y. Let's look at another example. For example B, we have something raised to the 4th power. So we're expecting to get possibly 4 x-intercepts. It could be less than that, but at most 4. I can see that I have each of the terms is divisible by 4 and x squared. So I'm going to factor a 4x squared out to the front for these. So I'll have 4x squared on the front, and then we'll be left with an x squared plus 3x minus 10. This factors into x plus 5 x minus 2. All right, so before I find my intercepts, I want to make sure that I get this factored completely. For our x-intercepts, we're going to let this equal 0. This one here is going to give us x equals 0. This one here is going to give us x is negative 5. And this is going to give us x is equal to 2. So we think that our x-intercepts are going to be 0, 0, negative 5, 0, and 2, 0. When we were looking at the original equation, we saw that the degree was 4, and so we were expecting to get at least 4, or at most 4 x-intercepts. We can see that we've got this intercept showing up once, and this one's showing up once. This one's actually showing up twice. This is what we call the multiplicity, because that exponent there was raised to the 2nd power, x to the 2nd power. This will also tell us something about the graph when we go a little bit further in this section. Again, this is called the multiplicities. Let's think about what the y-intercept is for this function. We're going to plug 0 in for x. And whenever we have something that's factored out to the front, when I go to plug 0 in, right out of the gate, this whole entire thing is going to be equal to 0, so I don't even have to do any more work. That also is going to match with what we were seeing in our x-intercept. We think that 0, 0 is our y-intercept. That's matching this x-intercept that we had over here. Example C, something raised to the 3rd power, so we're expecting to get 3 zeros potentially. Because I have 4 terms here, I'm going to factor by grouping. So I'm going to group the first 2 terms together, group the second 2 terms together. In the first two terms, I can factor out an x squared, and I'm left with x minus 3. And then I want that second set of parentheses to match. And then I think about what would I have factored out to create an x minus 3 in the parentheses. And it looks like that would be a minus 1. This will give me minus x and then plus 3, and that matches what I had up here. Now we'll group together the x squared minus 1 and the x minus 3. This is a difference of squares that factors into x plus 1, x minus 1. And then as far as my x-intercepts go, looking at 0 equaling this factored version, I get negative 1 as one of the zeros. I'm getting 1 as one of the x-intercepts, and 3. For our y-intercept, we're going to look at f of 0, which is 0 cubed minus 3 times 0 squared minus 0 plus 3. The y-intercept will always end up being this constant value that's on the end if there is one. And so our x-intercept in this case, or sorry, y-intercept in this case is 0, 3. All right, one more example. X to the 5th power, we're expecting to possibly get 5 x-intercepts. I can take an x and factor it out of each of these terms to start. So I have x to the 4th minus 5x squared plus 4. Because I've got something raised to the 4th power, I think that it might be a quadratic in disguise. So let's let u equal x squared, so that u squared is equal to x to the 4th. So this is like u squared minus 5u plus 4. And this factors into u minus 4 and u minus 1. And then let's switch this back to x now. X squared minus 4 and x squared minus 1. These are two difference of squares, so I get x plus 2 and x minus 2. And then I also have x plus 1, x minus 1. And it looks like I'm going to end up with 5 x-intercepts here. So our x-intercepts are going to come from each of these components equaling 0, right? So it looks like I'm going to get 0, 0 is one of them. Negative 2, 0 is 1. 2, 0. Negative 1, 0. And 1, 0. So those are my 5 x-intercepts. For my y-intercept, when I plug 0 into the original equation, looking back up here, I'm going to get 0 here, I'm going to get 0 here, and I'm going to get 0 here. So 0, 0. It turns out that when I have my x-intercept going through the origin like this, my y-intercept is also going to go through the origin, and so those two usually match up if you've got 0, 0 as one of the intercepts.